Hello, guys. Last week, kind of around quiz time, I know some of you had been caught up on our lessons. We did day 5, or at least part 1 of day 5, where we introduced absolute values. And we said an absolute value is the distance we are from 0. We know, of course, that an absolute value, distance can't be negative. Otherwise, you have a no solution, if that's the case. We use these bars to represent absolute value. Anything in there is what we're taking the absolute value of. And when we say the distance from 0, we're of course maybe talking about this. If you have, let's say, the absolute value of x equals 3. So the absolute value of a number is equal to 3. Well, that means your distance from 0 is 3. That could be 3 to the right, putting you at positive 3, or that could be 3 to the left, putting you at negative 3. Both of those would be an answer. Both those would be. So you get x equals negative 3 and x equals positive 3. And we saw with these that in order to solve them, step 1, you want to get the absolute value by itself on one side, kind of like we would do with a variable in a normal equation. Step 2, check for a negative on the other side. Okay, 22 is positive. So then step 3, you split and solve both. Well, here's the thing. You could go 22 to the right. That'd be a positive 22. Or you could go 22 to the left of 0, which would put you at negative 22. And then you work these out the same way. Add 11, but you get 2 very different answers. And then graphing these equations is just a dot and a dot. And we saw some examples of no solution. We saw it here. You divide by negative 5 to get the absolute value by itself. You look over, and then all of a sudden you look over and you say, wait a minute, that's equal to a negative 7. That's not right. Distance can't be negative, so that'd be a no solution. And so today, guys, we're rocking part 2. So this is part 2 on page 2. I'm sorry, on page 18. And again, guys, our steps are the same. Step 1, get absolute value by itself. Step 2, we're still going to check for negative numbers on the other side. I'm sorry, a negative number on the other side. Those two things are the same, but guys, check out what we're talking about here. We're going to tackle some absolute value, inequalities. That's what this chapter's been all about. So these are going to have greater than, less than, greater than or equal to, less than or equal to signs. Now the difference is going to be, wait a minute, using the word and or. So guys, absolute value inequalities, these are really just compound inequalities. These are really just compound inequalities. And let's take a look as to how that is. So first we're going to tackle what's called an and problem. Now we're told that that's because the absolute value of something being less than a number is going to put us in an and situation where a shading is going together. But let's see why. Right? Let's prove it. Let's prove it. All right. So first step, get absolute value by itself. We got a -1 shown here, so I'm going to add 1 over. That is less than 6. Okay, so step 1's done. Step 2, check for a negative number. Now here's the thing. If it is less than a negative, it is a no solution. But here's the tricky part. So less than, no solution. Now, if it's less than a negative number, this is less than 6. We're good with that. Hey, we're cool with an absolute value being less than 6. There are distances that are positive less than 6. 5, 4, 3, 2, 1. Yeah. Now, the problem we could run into is if we're greater than a negative, well, now, wait a minute. If we're greater than a negative number, won't that always be true? Yeah, an absolute value, guys, is always greater than a negative number. If that's the case, you've got infinitely many solutions. So if we're greater than a negative, that's infinitely many. If we're less than a negative, well, absolute values can't be less than a negative. That's no solution. But we don't have that here. So now we split. We say, okay, we're good with that. So we split it into, if we go 6 to the right, but then here's the weird part, guys. Because we're jumping to the other side of the number line, we've got 2x minus 1, same thing, right? We have to flip that sign. You flip it. Whenever you split this up, you have to flip that sign, and we have negative 6. It's almost like you divided this side by negative 1, which caused that to flip. And so now we solve these the exact same way. Check it out. Add 1. 2x is less than 7. Divide by 2. X is less than 3.5. Oop. How about over here? Add 1. 2x is greater than negative 5. Divide by 2. X is greater than negative 2.5. And we said earlier that this was going to be an and problem. That's what it said. Now let's prove it. Here's how we prove this. That anytime you have an absolute value that is less than a number, you're shading in the middle. Check it out. Here's our number line. Negative 2.5. 3.5. Okay? And we've got an open dot there and an open dot there. No equal to, no equal to. Now, if x is less than 3.5, less than, we're shading to the left. But then x is greater than negative 2.5. We're shading in the middle. So it is an and problem. Ha ha! I see that. I see that. How about this? Let's do an OR problem together, and then I'm going to let you guys try 2 on your own here. Let's try an OR problem together. So now we're busting out OR, and that's going to be whenever our absolute value is bigger than a number. So when our absolute value is bigger than a positive number, I'll specify. Yep. And so let's try this one, guys. Let's prove it. Prove it. Well, we have 3 times our absolute value. So step 1, get absolute value by itself. If that's 3 times that, I'm going to divide by 3. One's from each side. Cancels out. Divide that. So absolute value of 2x plus 4 is greater than or equal to 2. Now step 2, check for a negative number. I see a 2. We're cool with our distance being bigger than 2. Yeah, we're cool with our distance being 2 or bigger. Sure. So then we split it. 2x plus 4 is greater than or equal to 2. And 2x plus 4 is, flip it good, less than or equal to negative 2. Okay. So now we solve, subtract 4, subtract 4. Again, the steps are the same from here. Solving these are identical, but we're going to get different solutions. So 2x is greater than or equal to negative 2. 2x is less than or equal to negative 6. Divide by 2. X is greater than or equal to negative 1. And x is less than or equal to negative 3. Huh. This is going to be an interesting graph. So we're bigger than or equal to negative 1. We're smaller than or equal to negative 3. Let's see what happens, guys. Now don't forget, when we're talking about a number line, the bigger the negative, the smaller its value. So check it out. Negative 1 is bigger than negative 3. So we got, looks like a filled in point there, and actually a filled in point there, isn't it? And then if x is bigger than or equal to negative 1, we're shading to the right. If x is less than or equal to negative 3, we're shading to the left. And this is a good old-fashioned OR problem. Hey, so we just proved it. So anytime you have an absolute value that's bigger than a positive number, we know that our shading is going to be greater, right? The distance is going to be greater between these points. And with and, anytime you have an absolute value that is less than a positive number or equal to, could be equal to, you know your shading is going to be in the middle because our distance is going to be less than that, right? These 2 points are going to be that far apart or closer. Okay? So I'm going to let you guys try number 2. So you will try number 2 and see if you can give me your best shot on this number 2. Try these 2 problems for me, guys. Go ahead. Let's see what you guys are thinking here. So you start off, subtract 10. Gives us 8. Hey, we're good with that. A distance that is less than or equal to 8. Okay, so it's going to be an and problem. We split. Write the same thing minus the bars. Those bars are gone. And when we split it, we also take out the bars for this one, but we have to flip the sign. So then we add for both. We divide by 3 for both. You end up with x is less than or equal to 4. X is greater than or equal to negative 4/3. And when we go to graph it, you end up getting we're bigger than or equal to negative 4/3, but we are less than or equal to 4. Shading stuck in the middle, that's an and problem. And then with this one down here, it's already set up. We're good to go. So our distance is bigger than 15. That's perfect. So we split, we solve. Divide by 5 at the end. X is bigger than 1. X is less than negative 5. Well, there's no number in existence that's both those things. We're bigger than 1. We're less than negative 5. That is an OR problem. So thank you very much, guys. Good day today.